Statistics. Introduction of mean, mode, median of data, mean of group data, finding mean through direct method, finding mean through assumed mean method, finding mean through step deviation method. Statistics. In class 9th, we have seen raw data, organized data, mean, mode, and median of data. Mean of group data. Let us take this frequency table. This table is showing ungrouped data of marks obtained by 30 students. In the table, observations are given in first column and number of observations, that is, frequency of that observation, is given in second column. The third column showing the product of observation into frequency of that observation, that is, value of that observation. We have learned that mean is equal to sum of observations upon number of observations. Therefore, mean is equal to sum of observations, that is, sum of marks obtained by number of observations, that is 30. We get mean is equal to 1779 by 30. Therefore, mean of the marks we get is 59.3. Mean is denoted by x bar. Therefore, from above example, we can see that x bar is equal to summation of fi times xi from I is equal to 1 to n by summation of fi from I is equal to 1 to n. Direct method. Let us group the given data of marks in class intervals of width, say 15. For our convenience, we simply arrange this table as shown. Now for each class interval, we assume that midpoint is a representative of that class interval and this midpoint is called as class mark. We can find out class mark by class mark is equal to upper class limit plus low class limit by 2. The class mark of class interval 10 to 25 will be 10 plus 25 by 2. That is equal to 17.5. Similar way, we can find out class mark for each class interval. Here we assumed as class mark of each class interval is an average observation for that class interval. Therefore, sum of observations for each class interval is written in the last column. The sum of all values in fourth column gives us summation of fixi, that is, sum of all observations, and sum of frequencies in second column gives us fi, that is, total number of observations. Therefore, mean of the given data will be x bar is equal to summation of fixi by summation of fi. If we put value of each, we get mean is equal to 62. This method of finding the mean is known as direct method. We have seen two different mean values through two different methods for same data. It is only because of the midpoint assumption in direct method the value 59.3 is exact mean, while 62 is an approximate mean we get in direct method. Assumed mean method. When the numerical values of xi and fi are large, to reduce its tedious calculation, this method is used. We can do nothing with fi values, but we can change each xi to a smaller number by subtracting an assumed mean, say a. And therefore, we can easily get sum of observations for the class interval. The first step in the process is to find assumed mean, and the assumed mean is taken a central value of xi. We can choose 47.5 or 62.5 as assumed mean. Let us choose 47.5. The next step is to find the difference di between a and each xi. That is the deviation of a from each of xi. The difference d for each class interval is shown in fourth column of the table. The sum of deviations of individual class interval is given in fifth column of the table. And sum of all deviations is given by summation of fi di. Now in equation of mean deviation, each value of d is difference of respective x and a. Therefore, instead of writing di, here we can write xi minus a. Now multiply fi with the terms of bracket and separate each term. We get summation of fi xi upon summation of fi minus summation of fi a upon summation of fi. Now summation of fi xi upon summation of fi is x bar, and summation of fi cancels with summation of fi. Therefore, mean of the deviation d bar is equal to x bar minus a. We know values of mean deviation d bar and a. Therefore, mean x bar is equal to d bar plus a. Putting values, we get x bar is equal to 62. Therefore, in assumed mean method, the mean of the marks obtained by students is also 62. Now the step deviation method. This method is also used to simplify the tedious calculations. We have seen this table in deviation method. The values of di in fourth column are of the multiple of 15, and 15 is the size of each class interval. Therefore, if we divide the values of column 4 by 15, we would get smaller numbers to multiply with fi. Let us assume new values are ui. Therefore, ui is equal to xi minus a upon h, and these are the values of ui for respective class intervals. The mean of ui is summation of fiui upon summation of fi. By putting values, we get u bar is equal to 29 by 30. Now we have u bar is equal to summation of fiui upon summation fi. We have ui is equal to xi minus a upon h. Therefore, put value of ui in u bar. Now, if we perform further calculations, we get the relation hu bar is equal to x bar minus a. From the relation, again we get x bar is equal to 62. So, by step deviation method, again we get 62 as mean marks obtained by students. Summary. In this chapter, you have studied the following points. 1. The mean for group data by direct method can be found by x bar is equal to summation of fi xi upon summation of fi. 2. The mean for group data by assumed mean method can be found by x bar is equal to a plus summation of fi di upon summation of fi. 3. The mean for group data by step deviation method can be found by x bar is equal to a plus into bracket summation of fiui upon summation of fi bracket complete into h. So that is all in this subtopic. We will learn some more about statistics in our next topic. Till then, keep learning.